0. For this particle B times 50. In the end, it will be the whole thing times velocity y. Right? And then if you calculate equal to 21.43. And the question is asks you how much kinetic energy is lost in this collision. So first we can calculate in the end, after the collision, what's the velocity? V squared root velocity x squared plus velocity y squared, right? That'll be the total velocity, and it will be 35.71. And then we need to calculate the kinetic change, the loss of kinetic energy. It's the initial kinetic energy minus the final kinetic energy. Well, the initial one will be 1/2 50 squared plus 1/2 50 squared, right? 1/2 m v squared. And that's the initial one. And the final one is 1/2 times 14, 35.71 squared. You understand here?
That's the initial for the x, and that's the initial for the y.
Total. That's the total.
The 1/2.
Here we are talking about the total velocity.
I get the bottom, 35.
That's the total for.
That's the total. But the 0.08,
right,
that's for x, right?
Because it only have a velocity
Right. So that's
x.
that's the kinetic energy along the x, and that's the kinetic energy along the y, minus
You
the
can think
total.
about this, yeah, but along y here is 0, the kinetic energy.
Right.
So here actually the total kinetic energy.
It's along x.
Yeah, it's
Right.
along x, but along y there's no.
And then
0.
plus the kinetic energy along the
Of b,
of b, which
this
is,
particle, which is along y.
and then you subtract
From
the total.
Final, yeah. The final kinetic energy.
Okay.
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 Yeah, but actually the same thing if you calculate as along x and y, because anyway this, if you need to write twice, right? 1/2 m times velocity x plus 1/2 velocity y,
Mhm.
right? And from this we know x squared y squared is equal to this 35.71
Mhm.
square, right? It's the same thing. So calculator got the difference is 85.71. So it's D for this question. is to look for the center of the mass, or the center of the speed of the center of the mass, 14 and 15. So if in the XY system, all the particles, okay, how you calculate the center of the mass is the mass of A, the position of A, plus the mass of B, position of B, if you have CD, the same thing, and then divided by the total mass, right? And Y the same thing. So in this case, M will be, because here the mass is, you're going to divide it, cancel it out, so I'm going to use gram as what it is. Or you can convert into kilogram. It's going to be the same thing.
0.4.
Yeah. But here, because denominator and denominator will use the same, you can cancel it out. Times 3 plus 50 times negative 2 plus 20. We don't know this, the x of this one. 50 plus 20. And the center of mass is at the origin, so it's 0. Right? We want you to calculate where is this particle, the 20 gram particle, to make the center of mass of this 3-particle system located at the origin. Right? So these need to be 0. The denominator won't be 0, right? The denominator needs to be 0. And then what we have is 120 plus minus 100 plus 20x is 0. 20 plus 20x is 0. So 20x is negative 20. And then x is negative 1. Right? So here you understand.
No,
You don't understand here?
I understand it, but I mean, I don't understand the next row.
So that's equal to 0.
Okay.
So the denominator needs to be 0. For example, I give you x over 100 is 0. X is 0. Right? So we know here is not 0, so here needs to be 0.
Okay.
And then that is 120
Okay.
minus 100
Okay.
plus 20x, that is 0.
Okay.
And then 20 plus 20x is 0. We just move it there, x is negative 1. Let me know which step.
How you got -1?